Now we are going to see about chemical kinetics. What does mean by chemical kinetics? The branch of chemistry which tell us how fast or slow the chemical reaction will takes place. That is known as chemical reaction. Whether the reaction, any reaction takes place, any reaction, the additional reaction or any reaction, elimination reaction, any reaction takes place, whether the reaction is very fast or slow, we can calculate through the chemical kinetics. Now thermochemistry, thermo means heat. The thermochemistry means how the heat energy changes will occur, so that we can calculate through the thermochemistry. That is known as thermochemistry. Now the reactions, exothermic reaction and endothermic reaction. According to heat, the reaction is classified into two types. One is exothermic reaction, another one is endothermic reaction. Exothermic means heat have to be liberated. Heat have to be outcome from the reaction, and that reaction is known as exothermic reaction. Endothermic reaction means heat have to be observed from surrounding. Heat have to be observed from surrounding. Or any other thing we are adding in a test tube. In a test tube we are adding some particle means heat have to be observed. So that reaction is known as endothermic reaction. In a reaction we are adding some particles in the test tube means if the heat will outcome means that reaction is known as exothermic reaction. If the heat will absorbed means and that reaction is known as endothermic reaction. Now enthalpy change. The heat is observing, liberated and the outcome no, that can be calculated and it will give some amount of heat. So it can be expressed in the it can be expressed in the terms of del H. It can be expressed in the term of del H. So what is mean by del H? It is the enthalpy change. The quantity of heat liberated or absorbed during a reaction is expressed in terms of enthalpy change. I said no, in the exothermic and endothermic reaction, heat will outcome or heat will income. In a test tube we are adding some particle, sometimes the heat will absorbed, sometimes the heat will outgoing. So what amount of heat is incoming and outgoing, it can be calculated through del H. Okay, so the del H, the quantity of heat liberated or absorbed during a reaction is expressed in terms of enthalpy change. So the del H means it is also classified into two del H. One is positive del H, another one is negative del H. Positive means heat observation. Positive means heat observation. If the heat is observed, then it is known as plus del H. This is an example for endothermic reaction. If the heat will outgoes means that is known as negative del H. That is an example for exothermic reaction. The reaction is classified into two types. The heat is outcoming and it have to be expressed in the term del H. Thermochemistry means the heat energy changes. I told about how the reaction is takes place in fast or slow. The time heat once it will outcome or it will be income. So we can calculate the rate of the reaction. What is the rate of the reaction? How we can calculate that reaction? We can calculate rate of the reaction. Rate which is equal to dx divided by dt. I told no, any reaction is takes place. Here one reactant we are taking, another one reactant we are taking, and it will go some under pressure and temperature, it will give some product. So we can calculate the rate of this reaction through this formula. Rate is equal to dx divided by dt. Dx means the mole concentration, change in mole concentration. Dt means time, second. Here 60 second is equal to 1 minute, so we are taking second. How many minutes that reaction is takes place in, and what is the change occur in the mole concentration. If we divided these two things, we can calculate the rate of the reaction. And what are all the factors will affect the rate of the reaction? Some factors will affect the rate of the reaction. The factors which influence the rate of the reactions are, these are all the factors which disrupt the rate of the reaction. Concentration of the reactant. First one is concentration of the reactant. Here we are taking two reactant, 2 or 3, any reactant. First one is concentration of the reactant, whether it is dilute hydrochloric acid or concentrated nitric acid, like that. What is the concentration of the reactant? That is a main part. The second one is what amount of temperature, whether the reaction is heating, process is done in the reaction, or cooling process, or what processes takes place. So second one is temperature. Third one is presence of catalyst. We are adding some catalyst to induce some reaction. So presence of catalyst. Fourth one is nature of reactant and solvent. What is the nature of the reactant? Whether the reactant is solid or liquid, it will have high temperature or it will dissolve in water easily, like that. The nature of the reactant and solvent. What solvent we are acting? For example, water is a solvent, or any solvent we are taking. HCl we are taking as a solvent, like that. Any solvent we are taking. So nature of the reactant and solvent. So we can calculate the rate of the reaction through this formula, dx divided by dt. Dx means, I said, change in mole concentration. Dt means time. And 4 factors will affect the rate. What are all the 4 factors? I said concentration of the reactant, temperature, presence of catalyst, nature of the reactant and solvent. Okay. Problems. We have to solve this problem according to the rate formula. In a reaction A plus B which gives C. See here 2 reactants we are taking. First reactant is A. And second reactant is B, and it will give C product. Okay. Here these 2 reactants is reacting with each other and is giving product number C. The concentration of C increases from the product concentration increases from 0.8 mole liter to 3.2 mole liter in 40 seconds. They given time 40 seconds and mole changes 0.8 to 3.2. What is the rate of the reaction? They are asking. We have to calculate what is the rate of the reaction. Okay, rate of the reaction formula, what I said, rate is equal to dx divided by dt, I said. So dx means what I said, a change in mole concentration. What is the change in mole concentration? Here 0.8 to 3.2 is a change in mole concentration. What is the time? 40 seconds. So we have to write the numbers here. We have to write that changes 3.20 minus 0.8 divided by 40 seconds divided by 40. So the answer is 3.2 minus 0.8 is 2.4 divided by 40. So the answer is 0.06 mole liter, and second also we have to write. Okay, so this is the rate of the reaction. Now another one problem is here, that one we have to calculate. In a reaction, same A plus B is reacting with each other and it is giving C product. The concentration of C increases from 0.4 mole liter to 0.8 liter in 20 seconds. What is the rate of the reaction? As usual, we have to calculate through the formula. Rate is equal to dx divided by dt. Here time, what is the time? 20 seconds. So 20, here dx change in mole, what? 0.4, 0.8. So 0.8 minus 0.4 is equal to 0.4 divided by 20. These two subtract, then we got 0.4 divided by 20. So the answer is 0.02 mole liter second. So this is the rate of this reaction. So through this formula we have to calculate. We can find out easily the rate of the reaction. See about reversible reaction. What is mean by reversible reaction? If this symbol will present, means that is known as reversible reaction. What is the meaning for this symbol? This reaction will occur in both direction. This direction also it will occur, and this direction also it will occur. So any two reactant, 2 or 3, any reactant is reacting with each other and it will give some products. Afterwards, these products will undergo the same thing, then it will give the same reactants. So it will done through this like also, and it will done through this forward like also, reversible like also. So this reaction will occur in both direction, and that is known as a reversible reaction. Irreversible reaction means we cannot get again the reactant. Reversible reaction means we can get through this and the products will give again the reactant. But irreversible reaction means what? It is totally opposite to reversible reaction. It cannot undergo this like. So this is known as reversible reaction. Now equilibrium. What is meant by equilibrium? The rate of the forward and reverse reaction are equal. The reaction is said to be at equilibrium. Rate of the forward and reverse. For example, what? Some reaction we are taking and it is giving some product. So it can be occur in both direction. This direction also and this direction also. So this rate of this reaction and this rate of this reaction both are equally happen means, and that reaction is known as equilibrium. Okay, both rate of this reaction is equal means it is known as equilibrium. Example for reversible reaction. Hydrogen iodide we are taking, so it will decompose into hydrogen plus iodine. Then again this hydrogen and iodine is reacting with each other, it will give hydrogen iodide. So this is an example for reversible reaction. For example, we are taking this. First this reaction is giving hydrogen plus iodide. Then again we are taking this reactant H2 plus I2. It is also given 2H. So this like also this reaction will takes place. Forward and reverse reaction takes place. So it can be easily reversible, and these two reactant, this reactant is giving these two product. Again these two product is reacting with each other, it is giving this reactant. So this is known as reversible reaction. And irreversible reaction means we cannot write the symbol like this. The reaction should not take place reverse, and that is known as irreversible reaction. For example, precipitate. Precipitate, for example, in a test tube we are taking some liquid and we are pouring something, then it will separate it. It will be settled down like a precipitate, like yellow color precipitate or white color precipitate. It will be settled down. Again we are reacting the same thing means this precipitate won't give the same reactant. So that is known as irreversible reaction. Example, silver nitrate plus potassium chloride we are taking. This KNO3 will combine with each other and this AgCl will combine with each other. Then AgCl precipitate will form plus KNO3 we got. So this precipitate again it should not give this same reaction. So that is known as irreversible reaction. In a test tube we are taking AgNO3 and KCl. Then we got some AgCl precipitate. Again this precipitate should not give the same thing. So it will done through single method only. So this is known as irreversible reaction. This is an example of irreversible reaction.